I would like to talk now about the next assignment, which is bouncing blocks. So if we click on this, that should take you to the next one over here. And this post, the assignment is to actually write a new program, bouncing blocks. And what I want you to do, or what the assignment is to have those blocks bouncing off each other. So if we look at that short little clip I put over here, you can see how they actually bounce. The behavior might not be the perfect behavior, and that's why I said it could be silly if you want to. Random, silly, it will be fine. The important thing is that you can demonstrate how to use two functions, these two functions that we're going to talk about it in a minute. Make sure that you know what you're supposed to submit. Don't want to have to regrade something that is already very explicit in the assignment. So let's click over here. And that will take me to this resource. To talk about this resource, we have to understand how the overlapping functions work. Take a look at these two blocks or rectangles. They don't touch each other, but these two do. For example, it could be that this one is overlapped by this one, or vice versa, depending how you look at it, right? The important thing is that one is on top of each other, or better yet, they have a point in common. Here it is. It's point inside rectangle. So the point of one of this rectangle is inside another rectangle. And that's pretty much what those two those two functions will do. Let's take a look at it quickly. Then we're going to talk about how we're going to add this to your animation program, because what I'm asking you to do is take the animation program and copy it onto this new program you're going to have over here. The animation already has everything, so all we have to do is just add a few pieces of code. But let's first understand how this works. And let me bring this over here. So this function, do rectangles overlap, takes two rectangles, R1 and R2. So the way you're going to be working on the bouncing blocks is by pair of blocks, because that's the way this was written. Okay, you could rewrite this in which it will take as many blocks as there are in the list. It's up to you. So my suggestion is to actually where did I put that? Is right here. Is to do it by pairs. But you can actually do it the other way around, which is rewriting this based on what already is there. Let me put this back by accident. I moved it. Okay, so let's go back over here and let's see how this works. And you will see that this is true for either one of these two setups. This could be rect 1 and rect 2, or this could be rect 1 and rect 2. It will not matter, because the important thing is one is inside the other one. So it's going to use another function over here, which is the helper function right here. Here's the 2 points that define the rectangle. And so in here, we have, like we talked before, let's go back just 1 second to this one over here, in which we talk about the properties right here. You can actually click on this one and you'll have more properties. But each rectangle has something called left, right, top, bottom. There is a lot more. So think about left represent the x coordinate of the left wall of the rectangle. Any point in that wall of the left wall of the rectangle has the same x coordinate. The same thing with the right side of the rectangle. Every point on the right side of the rectangle on that wall will have the same x-coordinate. Now, what about if you look at top and bottom? Well, they will both have any point on the top wall will have the same y-coordinate. And so it's the same with the bottom. So if we're looking at, I lost that thing again. Okay, so maybe we should just use this. Yeah, I cannot put the image within the actual code, but maybe we can think for a moment. Come back here. There you go. I need to see things, and I want you to see things too. Okay, there we go. Hopefully I won't be switching around anymore. So let's see, how does this work? So we pass arguments over here, like you have done before in other functions, and we pass a rectangle. So let's see what is being passed. Here's the use of that function over here. So A and B represent the actual sets over here, or tuples. So here we have A. It will look in one of those rectangles. It's going to look at the left wall. So that will be the x-coordinate of the left wall of the rectangle. The y-coordinate of the top of the rectangle. And then we have another rectangle. So these two belong to the same rectangle, and this one belongs to the other rectangle. That's the only way that we can see if this point, which is x and y coordinate, is inside the other rectangle. And this is pretty much the boundaries. If the x of that point is within the left and the right wall of the other rectangle, and also if we only look at that, that means that it could be anything vertically between those two walls. So that's why we need an and over here to restrict everything. We want to have that the x is between the two side walls and the y is between the two horizontal walls, the top and the bottom. And that's exactly what it's doing over here. So this helper function reduces the amount of thinking that you have to do inside here. We could put it over there, but this makes it much readable, much easier to read. How do we use this? Well, this is the beginning of the animation, right? You copy the animation. It's pretty much over here, right? So just like when you did functions before, the advice is always to put the functions right after the imports. So I would suggest to do the same thing. So these are the functions. Then after that, the rest of the program from animation will continue. Almost at the end, take a look. This is the end of the animation program. So right before the end of the animation of the program, of the program animation, you want to add this function call. So you don't have to call the other one, the isPoint, because isPoint is called within doRectsOverlap. So you should recall that this is the last part of what the animation program has before it draws the rectangle, the window surface, and that's the update. So in between the two of them, you're going to put this new piece of code. This is only a portion of it. And take a look. I have B3, one rectangle, and B2 is another rectangle. Now, here you're going to have, in animation, you have 3 rectangles. So you're going to have to think about how you're going to pair this up. And again, doRectsOverlap takes 2 rectangles. And then it's going to call the function isPointInsideRect. So it's going to look for a point from one rectangle, see if it is inside the other rectangle. That's what this is doing. Pay attention. That returns true if this condition is is true. If this fails, then it's going to just come out of here and return false. So you don't need an else false, because if this is true, it will exit the function and with the true, right? The same thing over here. Although here they did it the other way, which is the else. So technically, either one could be written. I think this is kind of a nice, quick way to do it, but this is more intuitive, right? Because this one, if it's true, if the condition is true, I want to return true. Otherwise, I'm going to return false. All right, so I gave you a tiny sample of what the code should be. And you'll see that funny things are going to happen. Make sure, number one, that the rectangles don't disappear and don't then stick together, okay? Actually, I should put that in. I'm going to add that over here, in here. So let's add it right now. So you know, we're aware of what I said. But they shouldn't leave the window or stick together. All right, there you go. Have fun. It's going to give you a little bit of work, but you can do it. Mostly what I think you should do if you run into trouble is to do a little drawing. I do that all the time.